Hi everyone, we are back and we are going to start to do our example problem with Jeweler Maker, strain without stress. How can we get this? So we're trying to make a die to form a new cufflink made of steel. We need to know how much stress to apply to the metal slab to reduce thickness to 3 millimeters. This die is simple channel, does not constrain the metal in the X direction, well lubricated. All frictional forces and stresses along the travel walls can be ignored. So if I look at this system, so here's our steel, so our material, so we have our coordinate system, so that's our first step. So we always need to define our coordinate system. Our second step is what are our material properties? If this is steel, Young's modulus is equal to about 100 gigapascals. We know steel is 200, but we can keep it general for metals. Our Poisson's ratio is 0.3. Our third step, we want to start to write out our stress and strain tensors and see what exists and what does not exist. So we can do the same thing for strain as well. So for stresses, clearly there's some stress pushing the material down in the 3-3 direction, and this should be a negative stress, but we don't know what this value is. The material is not constrained in this one direction. So when I push down, the material is going to expand in the 1-1 direction, so it should expand. We don't know what that value is either. But there will be no stress pushing back because there's no force exerted there in that direction. So there's no stress in the 1-1. When I push down, the material should want to expand out, but it's being constrained, so there is stress in the 2-2, and it should be most likely negative as well. Is there strain in the 2-2? No, because there's no change in length. So if there's no change in length, there's no strain, so the strain in the 2-2 is 0. And finally, there will be strain in the 3-3, and it should be negative. Now, do we know the strain in the 3-3? Well, we're given the initial thickness, basically in that direction, 6 millimeters, and we're told in the problem statement, so the strain in the 3-3 is the change in length, so the final length needs to be 3 millimeters minus initial 6 millimeters over 6 millimeters. So that should give us negative 0.5. So we know what this is. 1, 2, 3. 3 equations, 3 unknowns. We can solve that because we can write 3 equations. Specifically, I'm going to write out Young's modulus is 100 times 10 to the 9. Our nu is equal to 0.3. So let's go ahead and define those. I'm going to say equation 1. I'm just going to EQ1 equals E11, and E11 we don't know what that is. And we can actually set up some, actually let's set it up right now. We know that sig22 is 0. We know that E22, oh no, sig22 is not 0, excuse me. Sig11 is 0, E22 is 0, and I think that's, and then E33 is equal to 6 times 10 to the minus 3, 3 times 10 to the minus 3, minus 6 times 10 to the minus 3 divided by 6 times 10 to the minus 3. So we can go ahead and shift enter all that good stuff. So E11 is equal to 1 over y times sig11 minus nu times sig22 plus sig33. We can get that. So that's our equation 1. Equation 2 will be similar, except we just switch 2, and then sig22, oops, and then sig11 here, shift enter, and EQ, and we'll just paste here. Equation 3, be careful here. Obviously, I'm going through this quickly, but you don't want to make a silly mistake. But you can always double check your answer to see if something strange has popped up. And sig11. So those are my 3 equations. I want to solve for my stress and strain tensors quantitatively, so I'm going to solve EQ1, oops, EQ1, EQ2, 3 equations, EQ3. I can specify what I want to solve for. So I want to solve for E11, sig22, sig33, or you can try to let Mathematica do it itself. And we get a value. So let's double check our answers. So we said, right, that the strain in the 1-1 should be positive. So as I push down, it should expand. Good. Sig 2,2 should be compressive, negative here. And sig 3,3 is negative as well. So this is a nice way you can always double check your answers to ensure that you didn't miss a sign essentially somewhere. So make sure that you always connect at the end your answers with your intuition as well. Fantastic. So next time we are going to get into rotating stress states, and we're going to show you the plug and chug, Mohr circle, and our linear algebra approach. So we'll see you next time. Thanks. Bye.